Assalamualaikum and very good morning to Dr. Muhammad Inam Abasi. My name is Muhammad Sabri bin Sarkawi and my partner's name is Ehsan Ashraf bin Muhammad Amin. Today we will present to you about our project-oriented problem-based learning, and our project title is Design and Analysis of a Millimeter Wave Printed Microstrip Patch Antenna. For the abstract, this project is focused on microstrip patch antennas where we design the millimeter wave printed patch antenna on a dielectric substrate with a frequency of 38 GHz. Microstrip antenna has a numerous advantages in field of communication such as high durability, lightweight, ease of fabrication. Even though microstrip antenna had its bountiful advantages, patch antennas also experience some drawbacks on the narrow bandwidth and low gain. There are numerous designing factors affecting the radiating characteristics of antennas such as patch height, feeding techniques, substrate used in manufacturing of antennas. This paper is focused on the optimize the performance of design antenna by analyzing dimensional parameters as well as the material properties. This paper also studied the feasibility of enhancing the bandwidth and gain performance of the design antenna by implementing slot configuration. For the introduction, microstrip patch antenna has become highly valuable and have better prospect as compared to other conventional antennas. With the widespread development in wireless communication technology in recent years, the requirement of compact size, low profile, and broad bandwidth antennas has augmented drastically. Microstrip patch antennas has fulfilled the requirement and become popular due to its many alluring features such as light in weight, low profile, low volume, low cost, small dimensional, and ease of fabrication and conformity. Besides that, microstrip patch antenna can provide frequency agility, broad bandwidth, and feed line flexibility. Microstrip antennas are used in numerous applications, ranging from biomedical diagnosis to wireless communication. Next, I will pass to my partner, Ihsan Ashraf.
Assalamualaikum. So I will be explaining about the design and the simulations. In this project, all design and simulations of a rectangular microstrip patch antenna had been done using the CST Microwave Studio by choosing the following specifications. So the frequency that we use is 38 GHz. The dielectric substrate is FR4 and the conducting materials is copper. So this is our antenna design by using FR4. This is the return loss that we get by using FR4. As we can see, the return loss was negative 43.37 dB, and this is the VSWR graph. This is the surface current of the FR4. So this is the far field directivity in a polar form. This is the Cartesian plane. This was the 3D radiation pattern. So I will be continuing about the results and analysis. For the optimization data, first we will use the constant patch width, which is 2.34 millimeter. As we can see, as we increase the patch length, the frequency will be decreased and the return loss will be increased. So this is the graph that we produce from the data. So for the second, we will use the constant patch length, which is 0.92 millimeter. As we can see, as the patch width increase, the frequency is decreased and and the return loss also decrease. So this is the graph that has been produced by the data. And the third, we use constant patch length and width. As the substrate height is increased, the frequency is decreased, and the return loss is increased. And this is the graph produced from the data. So for the material analysis, we use 3 different types of materials, which is Rogers RC 5880. The second one was Taconic RF60A. The third one was Arlon Diclad 870. So as we can see, the size of these 4 materials, Taconic RF60A has a smaller size compared to the 3 others. And for the return loss, FR4 has a better return loss compared to the 3 others. And the bandwidth for the FR4 has a greater compared to the 3 other materials. So I will pass to Sabri to continue this presentation.
So for the bandwidth and gain enhancement, one of the techniques that are going to be used to enhance the bandwidth of the patch antenna is an intrinsic technique. There are 2 intrinsic procedures that can be applied, which are by increasing the substrate thickness and by decreasing the dielectric constant of antenna substrate. But we are going to increasing the substrate thickness only. This can be seen on the result in the table below. So as we increase the substrate thickness, as we can see, the bandwidth will be more increased. As to enhance the gain of the patch antenna, the width of feed line is decreased. The smaller the width, the greater the gain. So this is the graph that we produce from the data. This is the calculation for the material FR4. We use the epsilon R equal to 4.7. The tan is 0.025. The frequency we use is 38 gigahertz and the height is 0.16 centimeters. This is the continuous of the calculation. So for the conclusion, from this project, we had designed a millimeter wave microstrip patch antenna printed on a dielectric substrate with the frequency of 38 gigahertz frequency range. Then we had optimized the performance of the design antenna by analyzing dimensional parameters as well as the material properties. And lastly, we learned on the flexibility of enhancing the bandwidth and gain performance of the design antenna by implementing slot configuration. In designing the antennas, using the feeding techniques isn't enough to enhance the gain and bandwidth. There are several other techniques such as parasitic patch, slot, dual feed, shorting pin, air gap, dielectric, and defective ground structures are available to enhance bandwidth and improve gain of the antenna. The techniques such as parasitic patch and slot cutting are also used to improve the impedance matching of antenna, thereby the resulting in multiband and broadband performance. That's all from us. Thank you.